Okay, thanks everybody. I guess we'll go ahead and get started here. For those who are not familiar with myself or Ali, I'll just give a quick intro for the two of us. My name is Matt Caldwell. I'm the Vice President of Data Centers here at Albireo Energy. I've been with the organization for about 5 months now, learning about all the exciting things going on at Albireo and helping to advance our data center initiative. Ali Askew has 20 plus years of experience in the data center world. He's a real subject matter expert when it comes to EPMS and all things data center. So I'm excited to work with him and to present this joint webinar today on preventing data center downtime. I'm going to start off the webinar here talking a little bit about Albireo, just give you some background there, and then I'll transition over to Ali to get into the meat of the presentation. So those who are not familiar with the Albireo Energy name, Albireo is a part of Huron Capital. So the name's been around for a few years now, but the experience that we bring to the table goes back to the early 80s. And the data center experience there and working with data center customers goes back decades. Huron Capital saw a gap in the market in that there was no large independent provider of smart building solutions. So really the initiative of Albireo is to bring together the thought leaders in the industry and be able to provide that vendor agnostic, geographic agnostic focus on smart building solutions. A big part of that is the data center space, which is obviously a mission critical facility which has a high energy density and can really take advantage of the advancements in smart building technology. So let me introduce you to the team. Ali and myself both report to Jason and Phil, who give the strategic direction for the organization. We have over 400 employees and we're growing rapidly through acquisition and our organic growth. You see Mike Revok there as well, another data center industry expert. But overall, this is kind of the structure that we're working within. So smart buildings can mean different things to different people. So I wanted to explain what it means to Albireo Energy. And it's really everything from the building envelope inward, also looking at, the supplies for the facility where the energy is coming from. Specific to the data center space, we're really looking at the monitoring and management of the data center and critical infrastructure, ensuring the reliability and energy efficiency of that space. So in our data center services, you're going to see EPMS, BMS, and energy services specifically to ensuring uptime and creating an efficient environment for data processing. And within the data center space and our overall smart building portfolio, we're looking at the full life cycle of the data center. So ensuring not only that it's installed properly, but operating as designed, looking at continuous commissioning and ensuring that the facility is operating at its peak reliability and efficiency. Albireo has offices on both coasts of the United States and operates internationally as well. We've done installations all over the globe and can address your needs wherever you may be. We focus on several key verticals, and obviously you see here some of our customers in the data center space. These customers are largely weighted towards the financial industry, which requires a Tier 4 designed data center. This is an industry where the cost of downtime can be exponentially larger than some other industries, but this kind of gives you a sense of the trust that's instilled in Albireo in being able to service these customers at the high level that they require. Here's just an example of some of our data center installs, and the key takeaway here is that we are able to operate throughout the country and wherever you may be requiring our services. So with that, I'm going to turn the mic over to Ali Askew. As I mentioned, he has 20 years experience in the industry. and he's a real subject matter expert when it comes to EPMS and all things data center. So with that, Ali, I will allow you to take the reins here.
Hello, everybody. Thank you for joining our call today. And as Matt mentioned, Albireo does provide a full spectrum of data center services. And the part that I specialize in is the electrical power monitoring systems. And I've been doing this for the last 20 years. I've really focused primarily on EPMS systems and working with some really great individuals, very knowledgeable, very experienced team of data center design and operating engineers to really just kind of collect some key highlights that I wanted to share with you today. And as Matt mentioned, we were formerly Sky Technologies. Now we are Albireo Energy, and I'm heading up the EPMS division within Albireo, primarily focusing on EPMS systems. We do have some remote monitoring systems, primarily for electrical equipment, some facility command centers to consolidate multiple monitoring systems into centralized locations, and some SCADA systems. And from our client roster, you'll see a large focus on the financial sector, mostly investment banks, where uptime, high availability is key. But we do have a large number of colo and cloud clients as well. So that being said, I want to start kind of jumping into some additional slides here. Just a short list of some of our data center projects. Again, you may be familiar with some of these sites. And again, this is just kind of a small selection of them. We have over 120 active data centers that we're involved in. And that's not just the full list of all the construction, but just actively we're managing the EPMS systems.
Thanks, Ali. What are some of the main differences between EPMS and, say, BMS or DCIM?
That's a good question, Matt, because EPMS is a less common known terminology than a BMS and also DCIM. So sometimes I find myself explaining, what's an EPMS? Why do we need it? How is it different? Why can't I do this with the BMS? Or I have a DCIM, can it do that? The main difference between EPMS and some of the other monitoring systems that are kind of considered or can be foreseen as overlapping systems, such as BMS or DCIM, is that a BMS system is really a control system. It's a system that's used for the operation of the data center. And we're talking about, some of the mechanical components, chillers, towers, pumps, looking at some of the key alarms. So an operating engineer in a data center will be looking at a BMS system quite frequently throughout the day and throughout different shifts. And the BMS system is actively used for the control and operation of the facility. A DCIM, for example, is really a planning tool, capacity planning, white space management. So IT guys use that as much as engineers for making sure that the data center capacity is well managed. An EPMS system, on the other hand, is really a forensic tool. It's intended to capture data, to trigger certain alarms when there is an issue or problem with the power flow. So think of it like a security camera system that you put in, and you don't normally access it unless there is something missing and when there's a problem. But you do install it. It does capture the information, it records it, and when it finds problems, so EPMS is no different. It's really a forensic tool that will tell you how the power is flowing and when you need to pay attention to it. But normally you don't look at an EPMS system all day long. You set it and you forget it, and it does the job for you. It notifies you and such. And sometimes EPMS system will feed data into your DCIM or BMS for multiple reasons, like, again, looking at active loads versus planned loads. So talking about some of our EPMS platforms, we are platform independent. We work with a number of products from Schneider, Siemens, Iconics, and Eaton, and we look at customer need to really determine what the environment. And for example, a large number of devices in a data center with many meters and many components may work well with a Schneider structure-aware platform. If you have Siemens switchgear and, again, large number of devices, maybe we'll use a Siemens WinPM as your product. If you have multiple colo sites, unmanned sites, where we're going through broadband connections or wide area connections, Iconics works much better with low network bandwidth, so we may choose Iconics. So it really depends on what the customer has. And we look at the systems and evaluate what really fits. EPMS hardware, we look to do redundant servers. It's not a requirement. We could do single server environments, but in a 2N data center, it makes sense to have a 2N EPMS and have redundancy. And we use Cisco switches. Cisco is the industry leader when it comes to networking hardware. So we kind of differ in that compared to some of the other automation vendors out there. We use Cisco, although it's more complex to set up and also maintain. It is the best hardware you can put into your network environment. And they do provide industrial switches and firewalls. Equipment that we monitor are pretty much anything electrical, anything that's involved in the power distribution and power flow. Some of the functional highlights are we like layer 3 switching, where we can create VLANs. We like SQL databases. The nice thing with SQL databases, it's open platform. A lot of products out there, a lot of vendors out there look to lock down the database. They have flat files, they have proprietary databases where you can't just simply run a query against your trended data. You have to go back to your software provider, or you have to buy some special driver or component to read data from a database. But we pipe data to SQL, and anybody with SQL knowledge, or anybody who has some SQL DBA can easily manipulate the data that we're collecting. And we do provide a 24/7 help desk to support infrastructure, so any type of system outages or system issues, you can report to our 24/7 help desk. And we do provide on-site preventive maintenance services.
Great. Thanks, Ali. That was a good description. What are some of the causes of downtime for data centers?
Well, the most common that everybody knows is human error. And I mean, human error is a known fact. An untrained individual will go and operate something that they're not supposed to operate, or go into a space that they're not supposed to go into, and cause downtime. But some of the less known factors of downtime is really poor commissioning. If a system at the time of installation is not commissioned properly, at some point it's prone to malfunction. I mean, that goes for proper load banking over UPSs and generators, making sure that the breakers are tested with fail to open, fail to close. You do your sequence of operations testing, different failure scenario testing, and that everything is well documented. If you test your equipment properly during the installation and then lock it down, you really do eliminate some of the improper installation that causes downtime. And also, obviously, maintenance is a huge factor. You can do preventive maintenance on your electrical equipment, or you can do break fix maintenance on your electrical equipment. It's really your choice. And if you have high levels of redundancy, some of our clients opt to do break fix because it's cheaper, or it's perceived as being cheaper. But when you have downtime because of break fix, well, you can't really measure downtime with dollars because at that point it's really loss of credibility that's really priceless. So most of our clients do preventive maintenance on the electrical infrastructure.
Great, thanks. And Ali, you mentioned human error is the number one cause of downtime. How does EPMS help address human error?
Human error is really, again, caused by lack of training, lack of knowledge. So we take that into account when we're creating our graphics. So what you're looking at on this graphic screen is a dashboard style graphics deployment. And the dashboard is really important because it gives you the needle nose display of where your loads are. And when that needle nose reaches red, that's going to get your attention. You can't possibly ignore that. In the past, I had a client who came up to me during the time of graphics development, and this goes back over a decade ago, and said, I want you to develop graphics for my data center that are so easy to read that I'm going to bring my 5-year-old kid and have him look at it and identify where we have a problem on the graphic. That's kind of when I decided to go with this dashboard style. It's really no different on your car dashboard, and chose to use these red lines and blue lines and make it so easy that, as the customer put it, a 5-year-old can identify if we're reaching capacity or at capacity or exceeding capacity. And again, we could do this same type of dashboard with mechanical loads. I don't want people to get the impression that EPMS can only do electrical. EPMS can do dashboards on mechanical because sometimes it's tough to divorce mechanical from electrical when you're dealing with chiller loads and PUE calculations and chiller kW per tons, because electrical readings sit on the EPMS, mechanical readings sit on the BMS. But when it comes to dashboard, you may need to get data from both systems and display where these electrical loads are. Like a chiller kW per ton is a chiller efficiency rating. So a chiller that's really rated at, let's say, 0.5 kW per ton has exceeded that, then you know you have exceeded your chiller efficiency rating. So we do use that same concept for mechanical efficiencies.
Thanks, Ali. You mentioned that EPMS monitors a high number of points. How can EPMS help filter through all that noise?
It's really the experience of the integrator. An EPMS system has a large number of points. That's what makes EPMS famous, or in some cases infamous, because of the large number of points. People think of EPMS as, oh my God, I have hundreds of alarms every day or warnings coming in. How do I manage all of this? It's up to the integrator to really differentiate what's noise and what's an actual event. Because when you look at electrical equipment, the typical EPMS system that we build for a tier 3 plus data center has over 100,000 data points. And although some people argue the fact that data center environment is a static environment, it's not static. There's maintenance going on. There are equipment being powered up, powered down. So there are power disturbances. So it's still a moving target. And there is going to be actual events taking place, like a power disturbance, or a UPS doing a self-test, or a generator test, or some other type of testing event. So all of these coming in are events. And then you have alarms. Alarms are when something has exceeded a threshold. And then you have something called a noise. So if you're monitoring things like breaker trip units, they tend to create a lot of noise because of the large number of points. So if you get advanced trip units with 200 plus data points, and if you don't program it right, you're going to end up with a lot of alarms. So it's really on the burden is on the EPMS integrator to make sure that they're able to filter out the noise and not the actual events. And that's kind of where we differentiate ourselves. And when you look at this graphic here, a facility state page is something that we've been deferring to, where that single graphic page probably summarizes about 50,000 data points into a single graphic. And every one of those boxes refers to probably hundreds of alarms summarized into a single point. So you want everything on that graphic to be green, all the way from primary service switchgear down to your PDU level. And if, let's say, your UPS guy comes in at the start of a shift to do a UPS maintenance, you do a screenshot of your facility state saying, hey, my data center is in normal state right now. Everything is showing normal. And by the time you leave, I want to make sure that everything is going to display normal. So at the start of every shift, for example, people look at this and they know what's an alarm, what's not an alarm. They can click on these and go in depth into individual alarms that summarize into these single boxes. So we try to make it simple and easy to follow through use of summarizing the alarms and filtering out the noise.
Great. How does EPMS help ensure the data center is operating as designed?
Again, the experienced EPMS integrator is going to understand design intent. And an EPMS integrator should not just be someone who programs Modbus points into a system and then create a graphic that shows analog readings and alarm statuses. And EPMS vendors should be able to look at one-line drawings and identify A plus B associations on the systems, which is 2N redundancy, or N plus 1 redundancy, N plus 2 redundancy. These are very important aspects of an EPMS system. We can't look at an EPMS system as just a set of points that get mapped into graphics and alarms. It's really the understanding of the design and the design intent. So being able to interface with the design team, the engineers, the operators, the equipment manufacturers is a key role that the EPMS integrator plays. And we do play that role where we talk with the design engineers, the operating engineers, facility managers, and equipment manufacturers to really get a full picture of operation of the data center at its design intent level.
So that's how the data center operator knows if they have the desired redundancy?
Yes, a data center operator is expected to know the overall design of the facility. They need to know associations between the different equipment, like a 2N switchboard where you have an A side and a B side. But when we present the graphics for them in an A plus B fashion, when we display graphics of an N plus 1 system, like let's say you have 8 generators with an N plus 2 redundancy level, our graphics will show the redundancy levels, the summarization of the generators, and the capacity of each individual generator. So understanding those types of redundancies and reflecting it onto these graphics are key. And again, you see on this graphic, we're taking 2 power panels, A side and B side, and totalizing them, because when you're dealing with, let's say, a 250 amp breaker on a power panel, and it's at 100 amps, you may think, hey, I'm less than half my breaker capacity, but if you have another 100 amps on the other side, you're almost at capacity. So when you look at this 2N picture, you may get a completely different picture than just looking at a single side, meaning an N side.
So Lee, how do you define thresholds in critical alarms?
Defining the thresholds have always been an extensive topic of discussion with individuals involved in the installation and deployment of an EPMS. A good example is you have 480 volts, let's say, on the output side of your UPS. So what do you consider as an under voltage and an over voltage? Is it 3%, 4%, 5%, 6%? That you could ask that question to 10 different individuals and get 10 different answers. So how do we set those up? Well, understanding of the power flow, the power quality, and the equipment capacity are key. An EPMS integrator needs to understand that. The easy way out of this is just simply program the alarms that come with the equipment. Like a UPS system will have a Modbus register map. A PDU will have the same. So the easy way out is just program those in. If the alarm is active, show alarm. If the alarm is inactive, clear alarm. And then just simply show the analog readings of the kWs, kVAs, and volts and amps. But we go beyond that. We sit down with the design engineers, we sit down with the operating engineers, and we say, okay, when do you want to receive your thresholds and your alarms aside from the equipment alarms? So these are really user-defined custom alarms. So for 2N systems, for example, we have a warning at 45%. We have critical at 50%. Because in 2N configuration, if an equipment is at 50% capacity in a shared load environment, you're at 100% capacity when you lose your redundancy. Same with harmonic distortions. We typically recommend stuff like 7%. You buy these expensive power quality meters that can display harmonic distortions, power factors, phase imbalances, phase rotational errors, current imbalances, but unless you program those parameters, those meters will do nothing for you other than just report volts and amps. So we program all of those points in, like a phase imbalance, we do it at 5%, current imbalance, 10%. But again, with these types of programs, you have to know what's going to cause noise and what's going to cause an event. So we have certain trigger points where the alarm activates. Like under very low load conditions, current imbalance does not apply. But when you're at 10% or 20% load or more, then we activate the current imbalance alarm. So again, it goes back to working with engineers and operators to do this. And so if you choose to put all your electrical equipment on a BMS system, for example, BMS guys are mostly mechanical backgrounds. So they'll take a PDU and they'll just treat it as a black box with Modbus registers and program it in. But they will not do things like, oh, it's a 2N PDU, so let me do a 45% load, or let me do a power factor of 0.8. They will not program those things because they will not understand the power quality and the power flow of the PDU itself. And so that's kind of where EPMS integrators differentiate themselves from BMS integrators.
Great, thanks, Oli. Can you provide an example of a power disturbance?
The power disturbance is anything that could be line related or load related. A line related event usually comes from utility. A load related event is really what's triggered from within the facility. So let's take a load related event. If you go and start your chiller and you bump your chiller either start or stop without a VFD, or you do some type of EPO on some major equipment or do a hard stop on a major equipment, you could cause a load related event. It could be a transient, it could be a sag swell, but utility events are expected. Every data center will experience utility power disturbances. Utility is never 100% reliable. But load-related events, events that are caused by the data center equipment itself or the operators themselves, is what we would look to further investigate and see what's causing it. But that's kind of the two different types of events that I want to identify, line-related versus load-related.
Okay, and how does a data center operator know if it's a critical event?
Data centers are designed to operate and really provide reliable power and cooling to computers and computer-related equipment. So we defer that to the Computer Equipment Manufacturers Association, which was called SABIMA. Now they're called ITIC. It's IT Industry Council. And these equipment manufacturers, be it HP, IBM, Dell, Xerox, they came up with what's called an ITIC curve. An ITIC curve is a voltage magnitude variation based on percentage. So there's an upper limit and a lower limit of voltage variation that's acceptable for IT equipment. Like a voltage dip or voltage swell of 10% should not affect any kind of computer equipment. That's what the IT guys said, the equipment manufacturers said. They said we should be able to maintain and operate in an environment with a 10% variation of our nominal voltage. And then they said, well, depending on the duration of the event, we can tolerate bigger disturbances like a 20% dip or a 30% dip. So it's not just the magnitude of the voltage dip or swell, it's also the duration that comes into the ITIC analysis.
And Ali, how are data center operators notified?
It depends on what they prefer. It could be an email, it could be a radio annunciation, it could be audible, it could be a horn light, it could be an email going out to some type of portable device. So we really ask that to the operators and say, how do you want to receive this notification? And then we deliver it to them.
Okay, and what is the potential outcome of a power disturbance?
When you have power quality meters, and you take a power hit, the meter itself captures two things. It captures the voltage waveform, it captures the current waveform. A lot of people don't realize that the current, the ampacity, has a waveform as well. It's not just voltage. Voltage has a waveform, yes, but the meter also captures a current waveform that is overlapped in the same manner as the voltage waveform is. So in here we have two types of events, event 1 and event 2. They both show a similar voltage dip, but the current is different. In one case, the current goes from, the red line, by the way, is the start of the event on these graphics. You'll see the current is increasing. So when the voltage dips, the tendency is for the current to go up to maintain the same kVA. But you see in the first graphic that the current eventually drops below its original state. So that means you actually lost some load. In the second graphic, there's a bit of a current increase, but then it goes back to its previous state, meaning there was no loss of load. So voltage shows the cause, current waveform shows the effect. So you really have to be looking at both.
Great, we got some sample screens here. Could you describe that for the audience?
So a couple of sample screens we included in this webinar today just to kind of demonstrate that an EPMS system can show multiple components in different configurations. Like in here, this graphic itself shows pretty much 6 different switchboards with 6 UPSs, 2 static switches, and probably a few dozen breakers. And how is this relevant? Well, this is a 2N UPS system with N+1 UPS modules. So when you're doing maintenance, you're taking modules offline or you're taking switchboards offline, it's very important to see both sides of your system, meaning the A side and the B side, because when you're operating the breakers and the equipment, you need to confirm that the alternate side, the redundant side, is doing what it's supposed to do. And then in some cases you do a main tie main operation, or you could operate your static switch and put the systems on bypass. So those are all shown on this graphic. And in this graphic we're showing a high level incoming power. Primary service switchgear shows 27 kV coming in, going through a transformer, dropping down to 13 kV, and then it eventually goes down to the substations. And what you see here that I want to point out is, let's take a look at PSSA and SSSA, which are primary service switchboard and secondary service switchboard. And the voltages are different, but the kWs are fairly in line. Obviously, the ampacities are going to be different too. But you will see that the primary has a greater kW than a secondary, roughly about 28 kW difference, and 27, 28 kW difference. And that's your transformer loss. So you're losing about 27, 28 kW to the transformer between your primary and the secondary service switchboards. That's not really a metering error when you look at it. That's really a transformer loss. So you can see things like, what are my transformer losses? Well, anytime you install a transformer, you have a transformer loss, which is really attributed to heat and copper. And so you can see that type of a differentiation in these graphics. We also show the generator paralleling gear, and also the main distribution switchboards, just to see statuses of A side and B side.
Ali, what are some of the challenges to implementing an EPMS system?
The most common comment that we hear is it's too complex, too many parts, too many wires. We don't want to tie everything. It's tying in this equipment versus that equipment increases the complexity of the system. Well, we address those concerns through simplified submittals. Like here we have a riser drawing that shows all the cable requirements, point-to-point wire requirements of an EPMS system. So we have all the switchboards, ATSs, UPSs, STSs, and branch circuit boards going into a single wall enclosure with all the wiring requirements. So you give this to an electrician and they'll know exactly how to price the job and how to pull these cables.
Great. How is an EPMS investment justified in the data center?
That's a very good question, and that's kind of a challenge that we're all facing, not just as an EPMS integrator, but as design engineers, as equipment manufacturers. Do I really need an EPMS system, and why? There are a couple of justifications for investing in an EPMS system. An EPMS system has a much greater level of accuracy and detail than a BMS system. And what I mean by that is, for example, breakers. Breaker open closed activity on an EPMS system will be captured with millisecond timestamping accuracy. Why is that important? Well, if you have 8 generators paralleling onto a paralleling board, and all of a sudden your entire paralleling board went down because all the breakers tripped open, you want to know which breaker tripped open first. Like if a generator failed, did it fail because the board failed, or did the board fail because the generator failed? So to really forensically identify the root cause of an electrical failure, you have to have millisecond timestamping accuracy. A millisecond in the electrical is just as long as infinity, because that's all it takes for the equipment to go down. And so millisecond timestamping accuracy is something standard with the EPMS systems that are not really available with any other system out there. The second thing is really capacity management and planning. A lot of these data centers have design intent. Obviously, you're maybe building a 1 megawatt data center, or a 10 megawatt data center, or a 40 megawatt data center. Well, how do you measure that capacity? How do you manage that capacity? And how do you plan for additional capacity? Well, you really need an EPMS system to get a full picture of where your bottlenecks are. Is it at the utility level? Is it at the UPS level? Is it at the PDU, or at the branch distribution level? So an EPMS system will give you a full visibility into where your reserve capacities are, untapped capacities, Because the most common statement that you'll hear from data center managers are, oh, we're at capacity or we're reaching capacity. Well, if you don't have an EPMS system, you can't really safely answer that. And so that's kind of another reason why a lot of our customers invest in EPMSs, so that they can look at where their usage is, where their reserves are. And the third and the most important for some individuals is it's actually cheaper to install an EPMS than to throw points onto a BMS system. Because when you look at it, a BMS data point cost is on average between $1 and $1.20. So if you're tying in your UPSs, your breakers, your branch circuit metering, you could easily hit 50,000 data points on your BMS. And you do the math, it's going to cost so much more to tie it into a BMS when on an EPMS system, it's a fraction of that. It's really a $0.20 to $0.20 and to $25 to a EPMS point. So do you want to spend a quarter on a point, or do you want to spend $1 on a point is really the question. And it also bogs down the BMS. BMS systems and applications and controllers aren't really designed to handle hundreds of thousands of points, and EPMS systems are. And when you deal with an EPMS system, point count becomes less significant. It's really the device count. And having a trip unit with 300 points versus 10 points makes really no difference on the EPMS, but on the BMS, it makes a significant difference. Far less money to install an EPMS system and tie your electrical equipment into it than to put everything on the BMS.
Thanks, Ali. That was really informative. I'd like to open up a dialogue here. So as attendees, if you have any questions, you can type them into the comments section, and we'll get to those very shortly. In the meantime, Ali, a question from an email. Can I use an EPMS as a commissioning tool?
EPMS could be used as a commissioning tool. When we're doing a new installation, a new data center installation, and we're going through the 5 levels of commissioning, from component testing to pre-functionals to functionals to a full IST. A commissioning agent comes in with certain metering and monitoring equipment, portable equipment. But obviously, there are severe limitations to how that could be tied in to live energized equipment, especially if you're dealing with medium voltage. You can't really hook up electrical metering equipment in a safe manner. So we've had many conversations and requests in the past where they ask us to fire up the EPMS system and have it ready at the time of commissioning. So if there's a switchboard that gets powered up and is getting ready for commissioning, like a functional test, the commissioning agent will ask us, is your EPMS system online? Can I use it to see voltages and amps and power disturbances and transients? Of course. I mean, we want to be the first ones online. We want to be live on the EPMS side. So as the equipment is getting energized, EPMS starts its forensic captures immediately. And I'll give you another example of a project that I was involved in where they were having generator problems. And it turned out in a period of 3 days, they bumped their generators over 200 times. And we captured every one of those times. And the commissioning agent came to us and said, so were there any events captured on the generators? Because they seem to be having some problems. The commissioning agent had no idea that each and every one of those generators were bumped 200 times in a period of 3 days. And when we showed the event logs, they were baffled because nobody told them that that was the case, that the generators were being brought online, offline, dropping offline, breakers tripping open. So that's when they started drilling in and really identified that the programmers of the generator PLCs were deficient in their knowledge, and that they were actually not programming the generator failure scenarios properly, and that's when they identified the generator programmers' deficiencies through the use of the EPMS tool. So having it online at the time of commissioning became very important.
Awesome. Thanks, Ali. And a reminder to everybody, please go ahead and type your questions into the conversation tab there. Ali, thanks again. This was extremely informative, and just to reiterate some of the key takeaways that Ali has brought forward in the webinar here from my 15 plus years experience in the data center space. I feel as though EPMS is an often overlooked component to a reliable data center, and a lot of times that has to do with that being value engineered out, customers believing they can get the information they need through a BMS system, or an EPMS system being installed but not being configured or operated as designed. So I think what Ali has demonstrated here is that it's really in the integrator that you choose, and making sure that all the graphics and functionality of the EPMS tool are being used to their full capacity to monitor those large number of data points and ensure that the data center is up and running as designed. Ali, any final thoughts?
I do encourage people to contact us for any problems or questions or concerns you may have with your electrical distribution, power flow, electrical capacity, and we'll be happy to work with you to see how we can help. I mean, we do possess a good amount of knowledge of data center design, monitoring, metering, so we'll be happy to work with you on not just looking at drawings, but also looking at actual loads, maybe in some cases coming out to your site and looking at actual live equipment and live systems, and identify certain improvements and enhancements.
Yeah, and to echo what Ali just said, our contact information is right there, so please feel free to reach out to Ali or myself, and we look forward to hearing from you. If there's no questions, I think we're going to wrap this up, but we do appreciate the turnout. I think we had a good group here, and hopefully you guys got a lot out of this. So thanks again for your time. We will wrap this up here with a couple of minutes to spare, and look forward to hearing from y'all.